everyone. Our experiment today is entitled Acids, Bases, and Salts. There are three major classifications of substances known as acids or bases. The Arrhenius definition states that an acid produces hydrogen ions or H plus in solution, and a base produces hydroxide ions or OH minus. However, some substances like the base ammonia cannot be classified using this definition. Bronsted-Lowry theory defined acids as proton donors or give away an H plus, and bases as proton acceptors or gain an H plus. An acid-base reaction according to the Bronsted-Lowry definition is a transfer of a proton from one molecule or ion to another. Lewis proposed a third theory of acids and bases that is even more general than either the Arrhenius or Bronsted-Lowry theories. Acids can attach itself to an unshared pair of electrons in another molecule. Bases have available electron pairs. In other words, Lewis acids accept electron pairs, Lewis bases donate electron pairs. So a Lewis acid-base reaction is represented by the transfer of a pair of electrons from a base to an acid. It's frequently possible to tell acids and bases apart from one another by some of their easily observed chemical and physical properties. Acids have a sour taste. Lemons, vinegar, and sour candies all contain acids. Bases often have a bitter taste and are found in foods less frequently than acids, but they are nonetheless present in many household products. Many cleaners contain ammonia, a base. Sodium hydroxide is found in Drain Clean. Many bases, like soaps, are slippery to the touch. Aqueous solutions of acids and bases are electrolytes, meaning they conduct an electrical current. Some acids and bases are strong electrolytes because they ionize completely in water. Others are weak electrolytes that exist primarily in a non-ionized form when dissolved in water. The relative strength of an acid or base is the extent to which it ionizes when dissolved in water. Acids and bases change the color of certain acid-base indicators. Two common indicators are litmus and phenolphthalein. Blue litmus turns red in the presence of an acid. Litmus turns blue in the presence of a base. Acids react with active metals to yield hydrogen gas. Bases do not react with metals in the way that acids do. Bases react with many oils and fats. The concentration of specific ions in solution determines whether the solution is acidic or basic. pH is used to measure the concentration of hydrogen ions and therefore whether a substance is acidic or basic. Solutions with a pH of less than 7 are acidic, while those with a pH greater than 7 are basic. The pH scale ranges from 0 to 14, and a pH of 7 is considered neutral. Acids react with bases to produce a salt compound and water. When equal moles of an acid and a base are combined, the acid is neutralized by the base. A salt is composed of a cation from a base and an anion from an acid. Not all salts are neutral. Some can be basic, others acidic. In this experiment, the properties of acids and bases will be investigated in terms of color reaction with common indicators: blue and red litmus paper, methyl orange, and phenolphthalein. Relative strength of acids and bases will also be investigated in terms of reactivity of acids with marble chips and reaction between calcium chloride and sodium hydroxide solution. Lastly, various salts will be classified as neutral, acidic, or basic using litmus paper test. And that's it for the experiment. An American historian and former US president once said, believe you can, and you're halfway there. Take care, and goodbye everyone.